Okay, as converting to a smart notebook, we're going to turn to one of the very last pages in your notes. We are going to summarize all the different transformations that happen to your functions. And here we are. Okay. Y is equal to AF of X. If you see a number on the outside, it will affect it vertically. In this case, it will create a vertical stretch by a factor of A. What do you think will happen if I put a number in front of the function that is less than 1? Say 1 over A. Think it will make it bigger or smaller? Smaller, so it'll be a vertical shrink. Now, if there's, instead of being on the outside, if there's something on the inside, then that will affect it horizontally. Yeah. So suppose you have a number less than 1. You would say that that would be probably a horizontal compression, would make it smaller, wouldn't you? But in fact, you realize that when things are on the inside, things get a little bit goofy. So, for example, x minus 3, is that a shift to the right 3 or to the left 3? The shift to the right 3. And we all went through a time where we're like, oh, it should be left because it's minus, right? You learn that on the inside, things are opposite. So if it's on the inside and you see a number is less than 1, it's not a horizontal shrink, it's a horizontal stretch. And if you see a number that's greater than 1, you would probably think that it would be a stretch, but since it's on the inside, it's opposite. So it'll be a horizontal. Sure. Shrink or compression, either one is fine. So now we get to put together all of our findings about transformations. And I mean, this is something I use just about every single day in calculus. I don't necessarily refer to this piece, but second semester, I think sometimes you get frustrated if you're learning stuff that you're not going to use in the future. Second semester, I need you to be able to graph this. And in order to do that, you have to be able to understand exactly, the type of transformations that we're talking about. Now you look at that, you're like, well, what the heck? This is our highest scoring test of the year. Over 50% of the students get a 95% or higher on this test. You'll be great at it. But you have to be able to isolate the pieces. Again, outside is vertical, inside is horizontal. You can start to see what happens. You don't know what the sine function necessarily looks like, but let's just review. If it's on the outside, what will it do? Verticals, yep. And then also, if A is positive, what's going to happen? It'll go up, and if A is negative, it'll go down. What other piece is on the outside? D. Yep, and that is a vertical shift. Then we get to the inside. If we look at that number in front of x, that's going to create a horizontal stretch or shrink, depending on its value, right? What if b is negative? What does it do if b is negative? Flips it horizontally, so it will go to the left as opposed to the right. And then, not just c, but the entire piece here, solve bx minus c equal to 0. We said whatever you plug in to make 0, that's going to be your horizontal shift. That kind of puts it all together for us, right? So now what we're going to do is we are going to examine a graph of a function that we don't really have a good rule for. I'm going to align this because it is way out of alignment. But again, this will be a problem. It's in your assignment today. It's going to be problem number 11. And you have an example of it in your study guide. And you will have a problem like this on your test. So you want to make sure that you get this correct. Otherwise, the points will come off your test rather quickly. We don't want that, right? Because then it takes me longer to grade them. That's your concern, right? So here's what we're going to do. We're going to plot a few points. We're going to plot -3, -2. And plot -2, 2. Plot 1, 2. And we're plot 3, 0. And I'm going to connect it together. And this will be my function. So I just made one up. This is not a function that is a popular function. We haven't talked about it before, but it's a function nonetheless. And we're going to perform certain transformations to it. And this will test whether or not we really understand the operations. So let's look at our first example. If this is f of x, I would like to graph 2f of x. What does that mean? What does the 2 do to it? By a factor of 2. Vertical stretch or horizontal stretch? So will that affect the x values or the y values? It will affect the y values. So I'm going to make a new chart, x, y. And instead of doing, I won't do anything to the x values. I have -3, -2, -1, or I'm +1 and 3. But the y values, I will multiply all by a factor of 2. As I graph that, you should see that it looks like the same type of shape, but it's stretched by a factor of 2. Some of you might be asking, what is it stretched about? It's stretched about the origin, you know. So as you can see, this point 3, 0, it didn't move up or down at all because it has a height currently of 0. So the focus point is always the origin. Kind of like if you had your camera lens and you were zooming in, whatever. Okay. All right, so the next one, I have my x and y. And what are the two things going on here? Very good. Vertical shift is the +1. Horizontal stretch is the 0.5x. Now, it is a stretch because it's less than 1. How much is it going to be stretched by? A factor of 2. How'd you come up with 2, Michael? Yep, you're going to take the reciprocal value. So you can see that you have 0.5 here. What would people maybe want to do to the x value? They would want to multiply it by 0.5, but in fact, we multiply it by 2. It will take the x values and it will stretch them by a factor of 2. So that's what I do. -6, -4, 2, and 6. Then what do I do to the y values? I shift them up 1, so I add 1. So I get -1, 3, 3, 1. And when I plot these, again, I should get a shape that resembles something that has been stretched horizontally, but also has been shifted up a unit. And yeah, I think that does look a lot like my very first graph. It's just stretched horizontally, and it looks like it does have a slight shift to it. So I'm very happy with that. Any questions on that example? Yes. I multiply it by 2 because this value right here, the 0.5 on the inside, the 0.5 on the inside is going to affect it horizontally. And it's always going to do it by the reciprocal value. So if it's less than 1, it will create a stretch. So I multiply it by the reciprocal. So if you see 1/3, then you multiply it by +3. If you saw a 4 in front, what would you do? You take 1/4 of all the values. Okay, what do I have going on here? Vertical shift and a vertical flip. Yep, very good. So you need to apply these in accordance with order of operations. So, Ella, give me a number 1 through 10. 1. So if you plug in 1 here, the first thing we would do is we'd subtract 1. After that, we take the function value, make it negative, and then we'd subtract 3. So we need to apply it in that order. So I will first do the -1 part, okay? So x minus 1. What does x minus 1 do? Shifts it to the right one. So what should we do to the x values? Add 1 to it, right? What will most people do when they see this to the x values? They will subtract 1. But it's shifting to the right one. So we add 1 to all the x values. So we get -2, -1, 2, and 4. We add 1 to all those x values. Hold on, order of operations. So the negative is on the outside, so that will affect it vertically, right? I'm going off of this one right here. Always off the original, okay? So then it says to the y value, make it negative and then subtract 3. See that? Negative, then subtract 3. So that would be +2 minus 3. 2, make it negative, so -2 minus -5. Yep. And I'll plot that. And again, your new shape, you shouldn't see any horizontal stretches or vertical stretches, but you should see the same kind of shape, just flipped upside down and shifted. right? 1 and down 3. In fact, I do. It's a little hard to tell because these graphs are smaller than this graph, so they look a little bit different. Okay. And then the last one. What is the first transformation that we should apply? Horizontal reflection. The negative is on the inside. So whatever, if an x value was positive 2, it should become negative 2. So I will, in fact, change all of the x values. 3, 2, negative 1, negative 3. Do I add 2 and multiply by 2, or do I multiply by 2 and add 2? Yeah. So I multiply by 2, I get negative 4, plus 2 is negative 2. Multiply by 2, I get 4, plus 2 is 6, 6, and 2. That's cool. You can definitely see it stretched and then shifted up as well. I like it. And that's it. The very last page, technically that's stuff that we can go over if we have time, but I'd like to just put it aside. Without a doubt, I can go over that at any time, and it won't take very much of your work time. So we have an assignment, and anybody have their homework cover sheet on them? You can take that out. You can see that the second to the last assignment is page 194. I don't believe that we'll be doing the last assignment on your homework cover sheet. Okay. Don't cross it out yet, but I believe we will not be doing it. Okay. So I'm just saying it could happen that you know, I don't know. We have a snow day on Friday, then all of a sudden I would cover a lesson and then do something on Tuesday. So anyway. So you got the rest of the hour, okay? Use it wisely. Got 17 minutes. Go.